Basic Geometry Self-Quiz Number 1. In this quiz, we will take a look at the following topics: general problem solving, definitions in geometry, finding unknown angles of triangles, bisecting angles, slope, perpendicular angles, the Cartesian coordinate system, scale, transformations, the distance formula, the Pythagorean theorem, and the slope-intercept form. General problem solving? First, almost all problems have contained within themselves the solution or keys to the solution. Your task is to take apart the problem, organize what you know, and then use what you know to find the answer. It's an opportunity for you to show that you will not give up, but that you are a tenacious problem solver. You can think of most problems like a jigsaw puzzle. All of the pieces are there. You just have to organize them, make sense of them, and put them together. It takes effort and a willingness not to give up. Here's how this self-test works. You will be shown a problem. You pause the video, try to work out the problem, and then when you are ready to see the problem worked out, simply restart the video. If you are watching this on YouTube, to pause the video, you simply click on the stop sign. Then, to restart the video, you simply click on the go sign. First, we'll take a look at a few definitions in geometry. Most likely, you'll not even need to pause the video, but can just think of the answer. What is the name of a location in space on a plane or on a line? It's called a point. On a line, it's simply just a number, as in 2 on the number line. No, this is just 2 on the number line, and there's the point right there. It's a location. On a plane, a point is represented by an ordered pair, x and y. X comes first, then y, just like the alphabet. So we see the ordered pair here, and here is the location on the plane. Here we have the x-axis, you have the y-axis. Y is 1, x is 1, y is 2, and so that's the location, the point. It's dimensionless. We can't measure it, we only know where it is. And in space, it represents a number, as here we see the number 1, 2, 3, and we have the magenta ball. You can see that it is above the x-axis and to the right of the y-axis. But in this depiction, this two-dimensional drawing that we have right here, it's difficult for you to tell what its location is with regard to the z-axis. And the z would be coming this way, because I'm representing it only in 2 dimensions. So we'll take a look at this from 2 different angles. Here I have the y-axis, so it's easy for you to see that the magenta ball is out in front of the y-axis, and it's easy for you to see that it is above the x-axis. But here, it's kind of hard for you to tell if it's where it falls on the z-axis. So you have to see a picture from 2 different locations before you can tell that we are over 1, up 2, and out 3. So that's the x, y, and z, just like the alphabet. What is the name of the distance between any 2 points? If you need to, just click on the stop sign. It's called a line segment. A line segment has a start and it has a finish. And the distance between the 2, 1 dimension, the distance between the 2, in this case the distance between A and B, denoted here by its place on the Cartesian coordinate system, x is 1, y is 1, x is 3, y is 1. We have that. This is called a line segment. And here's the way we denote a line segment. This simply means line segment AB. What is the name of an infinite number of points that go in opposite directions? Click on the stop sign if you need to. It's called a line. Here we have line Y. We know it's line Y because that's its name right here. So it's line Y represented. This means that we have line AB. You can call this line AB because it has the points A, B located on it. But it goes on forever and ever in opposite directions, and it is called a line, as opposed to a line segment, which terminates. What is the name of the type of a line that has a starting point and goes an infinite amount in one direction. Click on the stop sign if you need to. It is called a ray. This is ray AB or ray R. A ray has a starting point and goes on forever and ever and ever. You know about a ray of sunshine. It starts at the sun, comes outward from the sun in a straight line, and goes on forever and ever and ever in Euclidean geometry. What happens when two rays get together sharing a common point? Click on the stop sign if you need to. They form an angle. And this part of the angle right here is called the vertex. We'll get back to some definitions, but now we'll take a look at a few problems. In the right triangle shown below, solve for the value of x. Click on the stop sign, get a piece of paper, and try to work it out. Alright, you know that all triangles, or you should know, that all triangles have exactly 180 degrees if you add up all of the internal angles. So if we add up all of the internal angles here, that will total 180 degrees. So here we have 3x plus 2x plus x equals 180 degrees. That's 6x. 6x equals 180 degrees. Divide both sides by 6, divide by 6, and we wind up canceling this 6 with that 6. Doesn't go away, it doesn't become 0, it becomes the number 1, and becomes the number 1. 1 times x is x, and any number over 1 happens to be that same number, so all of this just simply becomes x. X equals 180 over 6, which simplifies to 30. Now, you're not finished, because the next thing to do is to plug in your answer to see if it makes sense. Does it satisfy? So 3 times 30 is 90. So we have, now let's just erase all this stuff here. 3 times 30 is 90, and 90 is a right angle, so that worked. And 2 times 30 is 60, and so that looks pretty good. And 1 times 30 is 30, so yes, 90 plus 60 plus 30 does equal 180. What is the value of x? Click on the stop sign if you need to. Alright, you know that the total is 180 degrees. So we wind up with saying here we have 2.5x, here we have half of an x, and here we have 2x. 2.5x plus a half x plus 2x is 5x. So I have 5x equals 180. 180 degrees. Divide both sides by 5. And I wind up with this 5, canceling that 5, becoming 1, becoming 1. And 5 goes into 180 36 times. So x equals 36 degrees. So if you got 36 degrees, you're doing it right. Now, the last thing to do is to plug this in over here and see what you get. So you got 2.5 times 36, get you a number. You have half of 36, which would be 18, and then you have 2x, which would be 72. So this angle is 72, this angle is 18, and we have 2.5 times 36. That is 70, what, 90? Yeah, and so the question is, does that add up to 180 degrees? And it does. Alright, here we see an angle that has been bisected by line T, thereby forming angle 1 and angle 2. Angle 1 and angle 2 having been bisected out of angle ABC, that means that angle 1 and angle 2 are exactly the same amount. Bisect means to cut in half. So, what is the measure of angle ABC if the measure of angle 1 is 2x plus 5 and the angle measure of 2 is 4x minus 5? We want to know, the question is, what's the measure of angle ABC? In order to do that, we have to find out what the angle measurement is of 1 and 2. We know that 2x plus 5 equals 4x minus 5. I know that if I move this 5x to the other side of the equal sign, it becomes a positive. That means I now have 10 here. And if I take this 2x and I move it to the other side, it becomes a negative 2x. And so that means I have 4x minus 2x, which leaves me with 2x. Dividing both sides by 2. This 2 cancels that 2, and I wind up with x equals 5. That's not my answer. I'm on my way to the answer. Make sure that you answer the question. What is the measurement of angle ABC? So, I come back in here and I plug in what I know. 2x, 2 times 5 is 10, plus 5 is 15. That means this is 15 degrees. And if I look at 4x minus 5, 4 times 5 is 20, minus 5 is 15. This is likewise 15. It checks. The question was, what's this measurement right here? And the answer is going to be 30 degrees. So if you got 30 degrees, you're doing it right. What is this shape called? It's a square. I want you to press the stop sign and write down 4 or 5 things that you know about a square. All right, what we know about a square is that all of the sides are the same length. All of the sides being the same length, all of the angles are the same angle. That's 90 degrees, that's 90 degrees, that's 90 degrees, and this is 90 degrees. We know that a square has a perimeter. We know that a square has area. We know that the relationship of the area, let's say that the length here is 3, and the length here would be 3, because they're the same. It means our area would be 9 units squared. An interesting thing about it is if you know the area of a square, you know the length of the side. Here, our area is 9 units squared. The length of this side is the square root of 9. Square root of 9 is another way of writing 3. If this were the square root of 10, 10 units squared, then the length of this side would be the square root of 10. Now that's an irrational number. We can have an area of 10 squares in a square, and the length of the side is an irrational number. We'll get back to that later. This plays a pretty important role in mathematics. What is this shape called? Think about it. Then write down as many things as you know after you press the stop sign. All right, this is a rectangle. I know that it has 2 sides that are of equal length, that all of the angles are 90 degrees, that everything is parallel to each other. The opposite sides are parallel. I know that it has a perimeter. I know that it has an area. And kind of an interesting thing about this is that if I draw a diagonal from one corner to the other like that, I have a triangle. And both triangles are exactly the same. This is proof that if you have a triangle, the formula for the area of a triangle is 1/2 the base times the height, because this triangle here is exactly the same as this triangle here. It's just half of the area of the rectangle. What is this shape called? And write down, press on the stop sign and write down 4 or 5 things that you know about this. Okay, let's see how you did. Well, first, it's called a circle, and it has a diameter. It stretches from side to side, passing through the middle. It has a radius. The radius starts at the middle and goes to the perimeter. The special name of the perimeter of a circle is called the circumference. The relationship of the diameter to the circumference of a circle is known as pi. Pi is a perfect number. However, we can't represent it perfectly in our numbering system, so correct to 2 decimal places, it's 3.14. If that's not close enough, we can say it's 3.141. Or if that's not close enough, we can say it's 3.1415. It just depends on the amount of tolerance that you want to have, that you want to give this. So this is a perfect number that cannot be represented in our numbering system, so it is what we call an irrational number. What is this shape called? And write down several things that you know about this trapezoid. All right, what we know about a trapezoid. This is a base, and this is a base. The bases are parallel to each other. The bases are parallel to each other, and we can refer to one as base 1 and the other one as base 2. It doesn't matter which one you call base 1 or which one you call base 2, because all you're going to do is add them together. The other two lines are not parallel to each other. One of them can be at right angles. In other words, this one right here could be at a right angle like that, but that's not necessary. It's just that the other two lines are not parallel. We call this a trapezoid in this country. However, the rest of the world calls it a trapezium, so perhaps every once in a while you might hear somebody refer to that as a trapezium. It's just that we want it to be weird and different, so we call it a trapezoid. All right, now let's see. It has a perimeter, it has an area. It is a two-dimensional figure. What is this shape called? And write down a few things that you might know about it. It is called a rhombus. It has 4 sides that are exactly the same length. We know that because it's got this little line here. And you put that little hatch mark through here, it means that the other is equal. So this is congruent with that, and this is congruent with that, and that's congruent with that, and that's congruent with that. The angles, however, are not congruent with each other. So we don't have the lines through there. It is a rhombus. It is very similar to a square, except that a square has everything at right angles here, and the rhombus does not, so we don't have that. The nice thing about, some people refer to a square as a perfect rhombus, because all the sides are the same length and the angles all happen to be 90 degrees. That's in debate. It's not a big deal. Just know that a rhombus has 4 sides that are the same length and parallel to each other, and that the angles are not the same, except in one rare condition, and that's a square, and it has its own special name. All right, what is the measure of angle A? I want you to press on the stop sign and try to work this one out. All right, you should know that this is a total of 360 degrees. So that being a total of 360 degrees, we know that A plus B plus C plus D plus E plus 110 equals 360 degrees. How does A relate to B, though? Well, it tells us up here that B is just A plus 20. So we have A plus 20. And C, that's just A plus 40. And D, well, that's just A plus 60. And E, that's just A plus 80. So we have 1A, 2A, 3A, 4A, 5A. So we have 5A plus 20 plus 40 plus 60 plus 80. Was it 80? 20 plus 40 is 60, plus 60 is 120, plus 80 is 200, plus 200 degrees, plus 110 degrees equals 360 degrees. Subtracting 200 and 110, we get 5A equals 50. degrees. Divide both sides by 5. This 5 cancels with that 5, turning into a 1, turning into a 1, and 5 goes into 50 10 times. A equals 10 degrees. Now, we take a look at this and we go, we've got to answer the original question. What is the measure of angle A? We have it then. It's 10 degrees. So, go back and reread the original question, figure out what's going on, and make sure you answer the right question. There's something that we call slope. It's simply just the rise over the run. And rise is the numerator of a fraction, and run is the denominator of a fraction. Here you see we have the rise, that's the numerator, and the run, that's the denominator. We can do the long division on this, and we wind up with getting a number that we call slope. So if my rise is 2 and my run is 1, my slope is going to be a slope of positive 2. If my rise is 1 and my slope is negative 2, then I'm going to have a slope of negative 1/2. It doesn't matter where the negative sign goes in the numerator or the denominator or out in front. That's irrelevant. Okay, let's see this in practice. Here we see a rise of 4 and a run of 8. Well, 4/8 simplifies to 1/2, so the slope is 1/2, although the rise is 4 and the run is 8. We can take a look at this. Here we go. Here we have 1, 2. That's a run of 2 and a rise of 1. Or we could say I have a run of 3 and a rise of 1.5. Yeah. Or I can have a run of 4 and a rise of 2. So my rise is 2 and my run is 4. Anyway, I chop it, the slope stays the same, and I wind up with having here a slope of 1/2. It's positive because both my numbers were positive. This is a positive 1, so that's a run there of a positive 1, and then I would have a rise of 1/2. So I'm dealing with a positive number and a positive number, and so I wind up with having a positive slope. Here you see the purple line. It too has a positive slope of 1/2. We can see that because we go in a positive direction, 1, 2, up 1. 1 over 2 is the same thing as 1/2. If I went over 4 and up 2, I wind up having a positive 2 over a positive 4, and that simplifies to a slope of 1/2. So lines that are parallel have the same slope. If a line was perpendicular to the red line with the slope of 1/2, what would its slope be? Press on the stop sign, hammer out on this one. Okay, perpendicular means that it's 90 degrees. So here I have a line here in the black line that is perpendicular to the red line. The red line has a slope of 1/2. So let's check out what its rise over run is. Its rise, let's see, we're starting here, its rise is a negative 2 over 1. So negative 2 over 1 simplifies to a negative 2. So my slope is a negative 2. I could go, my run is a positive 1, and my rise is a negative 2. So I have here I have my rise, if I start here, if I start here and I go up, that's a positive 2, but now I'm moving in a negative direction with the 1. So I have a positive 2 over a negative 1. That 2 simplifies to negative 2. So the perpendicular to a slope of positive 1/2 happens to be negative 2, and there's the proof. All right, here we have a line segment G. We know it's line segment G because there's the name right there. We have a line segment G. What would the ordered pair be for the midpoint of the line? Click on the stop sign and try to work it out. All right, midpoint. That means halfway. Well, so we could, in this case, just count. We have 1, 2, 3, 4, 5, 6. We can count. Mathematically, we could also take a look at this. What's the difference between 8 and 2? And that answer is also 6. So that means the midpoint is 3 units further from this. 1, 2, 3. There's the midpoint right there. And so what are its coordinates? Well, we could count. 1, 2, 3, 4, 5. 5, comma 1, 2. 5, comma 2. For that, we can do that. It always helps if you'll make a sketch of what you're doing and what you're working on, so that you can visualize the math, so that you can visualize what you're doing. All right. What would the ordered pair be for the midpoint of line M? Click on the stop sign, try to work it out, come back and see how you did. All right, we have several ways of approaching this. One of them would be just mechanically hammer it out. The difference between 1 and 7 is 6. Half of 6 is 3, so I can just go over 3. 1, 2, 3. And so the midpoint falls directly above that. So there's the midpoint. But how do I calculate it? Well, the difference between 1 and 4 is 3. Half of 3 is 1.5, so I go up 1.5. So we're going to go up 1.5 there. And so here I have 1.5. That's not my answer because I have to add, I started at 1, so my y value is going to be 1, 2.5. So my x value started at 1, and 1, and that's 2, 3, 4. So my x value is going to be 4, and my y value is going to be 1.5. What is the exact length of the line segment shown? Click on the stop sign, try to work it out. Okay, works out that the Pythagorean Theorem is what you need for this. And the Pythagorean Theorem is a squared plus b squared equals c squared. If you don't use the Pythagorean Theorem, there are other things that you can use, the distance formula, but we're going to take a look at the Pythagorean Theorem for this one, or a simplified version of the Pythagorean Theorem, and that is, I'm really dealing here with just a right triangle. And so this right triangle has a leg of 1 and a leg of 6. I know it's 6 because 7 minus 1 is 6. So one of the things that I can do is I can square this, and so now I have 1 times 1 is 1, and then I can square 6, so I wind up having, and that's a really bad square, but I got 36, add 1 and 36, and so I get the square root of 37 is my answer over here. And the question was, what is the exact length? And that was the square root of 37 is what we came up with. We'll take a look at that. There's a simpler way of doing this that works every time, and it's just kind of a shorthand of the Pythagorean Theorem, and that would be you just take the lengths and you write them under the square root sign. Here we have 6. So 1 written under the square root sign is the square root of 1, and 6 written under the square root sign is the square root of 36. Now, I do not add the square root of 1 to the square root of 36. I can't do that. But what I can do is I can add 1 to the square root of 36. Excuse me, I can add the number 1 to the number 36, and then stick that number under a square root sign, and I wind up with a square root of 37. So it turns out that the question was, what's the exact length? And the exact length is the square root of 37. It's not real practical or real useful because we don't have something that will measure the square root of 37, so sometimes you'll have to turn that into a decimal or a fraction. So, what is the length of the line segment shown correct to 1 decimal place, tenths? Well, it's the same drawing, so we know that the length of the line is the square root of 37, unless you want to see me go through that again, and if you do, just back up the tape a little bit here, back up the video, and watch that. The square root of 37 I want to know it correct to 1 decimal place. So square root of 37. Well, I know that the square root of 36 is exactly equal to 6. So I know that the square root of 37 is going to be a little bit more than 6. So if I guessed 6.1, I could check that by multiplying 6.1 times 6.1 and see if I get a number close to but not larger than 37. Turns out you get, this is 37.2 or so. And so it's too much. So the number that I'm looking for is going to be 6.0, and that's correct to 1 decimal place. It's probably going to be about 6.04 or something like that. And you can check that by simply saying 6.04 times 6.04. And you have that. All right, this is the distance formula in Euclidean geometry. Nice thing about the distance formula is that doesn't matter which x you stick in, you'll still get the same answer. So if I stick this x in here, and I stick that x in here, I'm going to get the same answer. I'll prove it to you. So I can stick in 3 minus 2. 3 minus 2 is 1, but 1 squared is 1. Or I can subtract 2 minus 3. That gives me an answer of negative 1. And negative 1 squared, because we're squaring this up here, negative 1 squared is still 1. Well, it doesn't matter what you do with the distance formula here, then just follow the rules of PEMDAS. And so as you go through and follow the rules of PEMDAS, you would come up with an answer here. So why don't you try to use the distance formula and see if you can solve this. Click on the stop sign. All right, you should have come up with the square root of 37 if you're doing this with the distance formula. And so if not, go back and try it again, because that's what you should have gotten. Because if you do what's in the parentheses first, and then you raise to the power of the exponent, then you add and subtract, multiply and divide from left to right. There was nothing to do here. Then you add and subtract left to right. You do that. Then the final thing you would do is stick it under the square root sign, and you would have had the number 37 under the square root sign. Here we see a scalene triangle. The red line represents the altitude of the triangle. Scaling simply means that all 3 legs are different lengths. A right triangle can be a scalene triangle because you know the 3, 4, 5 right triangle, all of the legs are different lengths. And so if all of the legs are different lengths, it makes it scalene, but it also makes it a right triangle. What is the altitude of this scalene triangle? Press the stop sign. Okay, turns out no math is needed for you to make this calculation. You simply just count. 1, 2, 3, 4. The altitude is 4 units, whatever they are. Okay, when 2 angles complement each other, it simply means that they sum, they total to 90 degrees. A few examples are, here we see angle A and angle B summing together to be 90 degrees. So they have a common vertex and they have a common line. We don't know what A is and we don't know what B is, but we do know that they total or sum to 90 degrees. Here we have angle C, we don't know what it is, and we have angle D. We don't know what it is, but we do know that the total of the two is 90 degrees. They have a common vertex and they have a common line. All right? When 2 angles complement each other, it simply means that they sum or total to 90 degrees. Which examples below are complementary angles? Press on the stop sign, take a look at this, and figure out which ones. Okay, let's see how you did. Well, angle A plus angle B complement each other because they total to 90 degrees. And they have a common vertex and they have a common side. Angle C and angle D, angle C and angle E sum to 90 degrees, and they have a common vertex, but they don't have a common side. So these are not complementary angles in that sense. And looks like this does not work. And here we have angles HIJ. They sum to 180 degrees, and nothing here is complementary, so those are not complementary angles, and neither is this. So, all right. Here are a few more examples of complementary angles and the way that they are shown. Given that you have an angle that is 67 degrees, what is its complement? Now, it simply becomes a geometry problem. So we take a look at this and we say, all right, A plus 67 equals 90 degrees. I subtract 67 degrees from each side, and that means A equals 23 degrees. So the complement of 67 degrees is 23 degrees. When two angles sum total to 180 degrees, we say that they are supplementary angles, or they supplement each other. Here we see angle A and angle B. We do not know what the value of A and B is, but we do know that the value of A plus B is equal to 180 degrees. They supplement each other. What is the supplement of 95 degrees? Click on the stop sign, make a sketch. $85 degrees, because 85 plus 95 is equal to 180. Here we see a standard Rubik's Cube. How many stickers does it take to color all of the individual squares for the entire cube? In other words, this is one sticker right here. How many stickers would it take to cover the entire cube? Click on the stop sign, work it out. Okay, a Rubik's Cube has 6 faces. A face is the larger size, like right here. That represents the face. And on each face there are 3 times 3, or 9 stickers. So 6 times 9 is 54. So the correct answer is 54 stickers. How many of the smaller cubes, this being a smaller cube right here, how many of the smaller cubes would have to have at least one red sticker on it? Correct answer is 9, because when one face of the Rubik's Cube is all red, there are only 9 red stickers. What percentage of the exterior part of the cube is either white or red? So it is white or red, but it wants to know what the percentage is. That doesn't take into account the little black edge right here. It's not that at all. Well, it turns out that there are 6 faces on the cube, and one of the faces is red, and one of the faces is white, and so that means 2/6 of the cube is either white or red, and that simplifies to 1/3, and that's not the percentage. We do the long division here, and we come up with 0.33, and that's not the percentage, that's the decimal equivalent. In order to get the percentage per 100, we have to move the decimal 2 places, so the correct answer is 33%. And there's a big difference between 1/3% and 33%. That would be wrong, this would be right. A photo is made of a red arrow as depicted below. The blue dot measures exactly 1/2 inch in the photo. You know that the blue dot is really 1.5 inches in diameter. What is the real length of the red arrow? Click on the stop sign, try to figure it out. Alright, you know that the diameter of the blue dot here is 1/2 of an inch, which means that this is 1/2 of an inch. So this is 1/2 of an inch, 2/2 of an inch, 3/2, 4/2, 5/2. So 5/2 is how much it shows up in the photo, and that's the same thing as 2.5. But you know that each one of these dots is really 1.5 inches, not 1/2 of an inch. What's the relationship from 1/2 inch to 1.5 inches? 3 times. So you multiply this times 3. And you wind up with 3 times 2 is 6. And 3 times 1/2 is 1.5. And you wind up with 7 1/2. Now, 7 1/2 is still not correct. It's the correct number, but it's not the correct answer because it wanted to know what the length was, and you're dealing with 7.5 inches. It's very important that you tell the reader, you tell the person looking at your numbers what your numbers represent, because there's a big difference between 7.5 inches and 7.5 feet and 7.5 miles and 7.5 months and 7.5 light years and $7.5. So you've got to tell them what your number represents. All right. The relationship from one black arrow to the other is a rotation around the origin. So this is the origin of the Cartesian coordinate system, and our relationship is that this has rotated. If we rotated, let's give this a number here. Let's give this a name. This is A, and this is Z. So if we rotated Z counterclockwise 90 degrees around the origin, it would go like this. And if we rotated A clockwise around the origin, it would go like this. And so there you have it. If you have to stick a pencil inside your on your test and rotate your test physically, clockwise or counterclockwise, you can always look at the clock if you don't know what that means. If you have to look at the clock, if you have to rotate your test to visualize it, do what it takes to help you visualize the math. All right, here we see a relationship between the black arrow. It is a reflection across the y-axis. The point here happens to be 1, 1. The reflected point, if we reflect it across the y-axis, happens to be -1, 1. When you are mapping, when you're reflecting things across an axis, it's a real good idea for you to take that image, sketch it out, and look at it so that you don't make some silly little mistake with a negative or a positive. Because you'll see, if we were to reflect this across the x-axis here, then this point would be here, and we are dealing now with x is +1 and y is -1. And so it's a really good idea for you to make a sketch of what you're doing and to think about it. If this is a reflection across the x-axis and the tip of the red arrow in the second quadrant has the location of -2, 2, what are the coordinates for the reflection of the same point? In other words, we have this point right here. What are the coordinates for this point right here? And so I would highly encourage you to make a sketch and then work it out from there. You know that in this quadrant, x is going to be negative and y is going to be negative. So x is -2, y is -2. So in this case, the answer is -2, 2. The red line represents the graph of x equals negative y. It is a slope of negative 1. If the red diamond in the first quadrant is reflected across the red line, the center of its coordinates are negative 1, negative 1. A reflection is a 90-degree issue. So you see, here we go, that is 90 degrees to the red line, and the distance remains the same. And here we have a reflection, and that is 90 degrees to the red line. So the distances are the same. It's a really, really good idea to make a sketch when you're trying to figure these out. So here we have when the red diamond in the first quadrant is reflected across the line x equals negative y, what happens to the coordinates? In other words, what are the new coordinates? Click on the stop sign, make a sketch, figure it out. All right, let's see. The coordinates in quadrant 1 are x is 2, y is 1. They're both positive. We know that down here they're going to be negative, negative because it's in quadrant 3. But x is negative 1 and y is negative 2. Because we can draw a little sketch here. This line is perpendicular to the red line, and this is perpendicular to the red line. This is 90 degrees, and this is 90 degrees. This distance is 1.5 diagonals, and this distance here is 1/2 diagonal plus a diagonal, so 1.5 diagonals. The correct answer is negative 1, negative 2. The coordinates for the diamond in the first quadrant are 3, 1. What are the coordinates for the diamond in the third quadrant? Click on the stop sign. Well, x is negative 1, y is negative 3. So x is negative 1, y is negative 3. And how does that relate to 3, 1? So you can't just come in and stick a negative sign in front of this. It's a really good idea to draw it out. All right, point A has the ordered pair of 3, 6. Which of the following would contain point A? These down here, these are definitions for lines. So the idea is what line would pass through point A? Well, click on the stop sign, try to work it out. All right, works like this. You could just brute force handle this, and sometimes that's what you have to do when your math is short. So you could just brute force this and say, all right, let me stick in the value, let's see, x is 3, y is 6. Does 3 equal 6 divided by 2? Yes, it does. So, ka-ching, that one works. And you could say, all right, 6 equals 2 times 3. Yeah, that works. Ka-ching. You could look at this and say, all right, 6 equals 3 plus 2. No, 6 does not equal 5. Bang, that didn't satisfy it. And you could look at this and say, all right, y is 6, x is 3. Does 6 equal 3 plus 3? Yes, it does. Ka-ching, that works. So, which of the following? This one, and that one. I'll do the trick. However, there's something called Slope-Intercept Form. It's y equals mx plus b in this country. Some other countries use a different letter here than the m. We use the m because it comes to us from the French. It means mountain and it means slope. So y equals mx plus b is the slope-intercept form. If you've had algebra by now, you should recognize this. So if we have 8x plus 4y equals 2, if we can get this into the form of y equals mx plus b, we can tell several things. We can tell what its slope is, and we can tell where it crosses the y-axis. So let's massage on this a little bit. Let's see. If I move the 8x to the other side, I wind up with 4y equals negative 8x plus 2. And now, if I divide both sides by 4, and I divide this by 4, and I divide this by 4, dividing everything on each side by 4, this 4 cancels that 4, becomes 1, basically just becomes y. Y equals negative 2x plus 1/2. And so what this tells me is, if I have the Cartesian coordinate system, if x is 0, in other words, x is 0 right here, what is y? Y will be a positive 1/2. Because see, if x is 0, this whole thing becomes 0. And so I would, if this is, that's 1, and that's 2, and that's 3, and that's 4, and that's 1, and that's 2, and that's 3, and that's 4. X is, if x is 0, y is 1/2. So there's where I cross the y-axis. And what's my slope? Negative 2. So I go over 1, run if y is, so what's my slope? My slope is negative 2 over 1. And you will remember that slope is nothing more than rise over run. Rise over run. So I would go over 1 positively and down 2. So there's a half, there's 1, and there's down about 2. So I'm looking at a line that passes through the y-axis at 1/2, positive 1/2, has a slope of negative 2. All right, the slope-intercept form. We'll take a look at another example here. If I can massage this so that I get it into the y equals mx plus b form, I can do that. So I'm going to move the 2x over to the other side. Its sign changes, so I wind up having 2y equals negative 2x plus 4, because my 4 is positive. Divide both sides by 2, divide by 2, divide by 2, and divide by 2. This 2 cancels that 2, leaves me with y, and I'm now, negative 2 over 2 just becomes negative 1x. I don't even have to put the negative 1 there, I can just put a negative x. Plus 4 divided by 2 is 2. So I wind up taking a look at my Cartesian coordinate system to see what the slope is. My slope is a negative 1, and I pass through the y-intercept at 2. If x is 0, y is 2. So let's go 1, 2. So I pass through the y-intercept at 2, and my slope is down 1 over 1. Down 1 over 1. And so we are looking at a slope of about like that, passing through at the point y equals 2. Y equals 2. So I'm able to tell what my slope is, and I'm able to tell where I intercept the y-axis, so I'm able to graph this rather quickly. So we'll work one more problem here, the slope-intercept form. If I move the negative x to the other side, it becomes a positive x. So I wind up having y equals x minus 1. And that's in the right form now. So I take a look at the Cartesian coordinate system. If x is 0, y is negative 1. So y is negative 1 when x is 0. So we'll have that there. My slope is a positive 1, so I go up 1 over 1. And so I plot those points, draw a straight line that passes through those 2 points, and I wind up with having a slope of positive 1. Now, what's all that have to do with point A has the ordered pair of 3, 6? Which of the following would contain point A? Well, if you know the math, you don't have to brute force knock it out the way we did. You can simply come in here and say, all right, I can rewrite this to be y equals x let's see, y equals x okay, I can simply rewrite x equals y halves to be, let's see, let's just go y halves equals x plus 0. And if I multiply both sides times 2, I'll get rid of this 2 here, so I just then wind up with y equals 2x plus 0. So where is my y-intercept? My y-intercept is 0, and the slope of my line is 2. So I go over 1, up 2. Over 1, up 2. Over 1, up 2. And would that line pass through? Yes, it would. So that one checks. And you'll remember when we did this a while ago, that checked. All right, so let's erase a couple things here. And so we know that that one checked. All right, y equals 2x plus 0. It's already in the right form. Our slope is positive 2. Our x-axis is, where we cross the x-axis is at the origin. So the origin, and our slope is 2. So over 1, up 2. Over 1, up 2. Over 1, up 2. And this checks. Yes. Now we look at y equals x plus 2. Let's get rid of some of this. Y equals x plus 2. All right, our slope is 1. Our y-intercept is where y is 2. So we come over here, and our slope is 1. So we go over 1, up 1. Over 1, up 1. Over 1, up 1. Over 1, up 1. And so you see, A does not fall on the line y equals x plus 2. So it does not work. Now we'll check one more time. Let's check this. Our slope is 1, and our y-intercept is 3. So we come over, 1, 2, 3. And our slope is 1. Over 1, up 1. Over 1, up 1. Over 1, up 1. And so by using the slope-intercept form, we could very quickly see that this 2 checks. So that works, that works, that works, and this one did not. 2 ways of solving the problem. Brute force hammer on it, or be smart and use the slope-intercept form. Here we see both lines that have the same m value. Remember, m means slope, French word for mountain. So they have the same value. Their difference is the y-intercept. So we see x equals 1x plus 1. This one isn't really necessary. It's implied if it's not there. So we have y equals x plus 1. So our y-intercept is here, and our slope is 1. So we go over 1, up 1, over 1, up 1, over 1, up 1, and that gives us this line. And we come over here and we say our x, where we intercept the x-axis is at 5, because if x is 0, y equals 5, so here's 5. And our slope is a positive 1, and so it too is just over 1, up 1, over 1, up 1, over 1, up 1, over 1, and so forth and so on. So you can see that these 2 lines are parallel. They have exactly the same slope when you write it in the slope-intercept form. They're parallel lines. The difference is their y-intercept. All right, the red line is a straight line. The purple lines are parallel to each other. What is the relationship between angle A and C? Click on the stop sign if you need to. All right, let's see how you did. The relationship between angle C, we don't know what angle A is and we don't know what angle C is, but we certainly know that they supplement each other. We know that they add up to 180 degrees. So the relationship, they're supplemental angles. What is the relationship between angle A and angle B? Well, we don't know what A is, and we don't know what B is, but we certainly know that since these are parallel lines in a straight line, we know that A equals B. What is the relationship between angle C and B? Click on the stop sign. They are supplemental angles. Angle C, this is also angle C. This amount right here is the same as that amount right there, which, by the way, is exactly the same amount right there. So C equals D. But the question was, what's the relationship between C and B? And that is, they are supplemental angles totaling to 180 degrees. What is the total sum of angles A plus B plus C plus D? 360 degrees. If we start here and we go around, A plus C plus B plus D is 360 degrees. The black point is reflected over the y-axis. What are the new coordinates? Well, click on the stop sign. It's 3, 2. So let's see, it's reflected over the y-axis. That's this puppy right here. So we come 90 degrees this way over 3. So 1, 2, 3. And it would be here. What are its new coordinates? Negative 3, 2. The black point is reflected over the x-axis. What are its new coordinates? Click on the stop sign. All right, I hope that you see that there are rules that you could follow on this, but it would be a lot easier for you to just draw a sketch each time you have to come up with a question. Visualize what the problem is, and then come up with your right answer. The black point is reflected over the red line. What are the new coordinates? Click on the stop sign. All right, 90 degrees. A distance here of half a diagonal, one full diagonal, two full diagonals. So 2.5 diagonals. Distance here, half a diagonal, one full diagonal, two full diagonals. I am at -2, -3. So -2, -3 is the reflection of that. And here I was at 3, 2. So again, draw a sketch. Visualize what's going on. Don't just rely on memorizing a bunch of confusing rules. This concludes your self-test, number 1 for basic geometry. Your comments, questions, and suggestions are always welcome, encouraged, and appreciated. you may write to me at alanmorris@yahoo.com.